Okay, welcome back. This is lesson 2 on direct, inverse, and joint variations. Now on the board, let me just explain. This word problem we're going to solve in a few moments. Okay, so I just had to write it up here before the video started. But I want you to notice on the board, okay, there are many things you're going to learn in science, coming up in chemistry, in physics, okay, coming up in your academic career, okay? And all of these equations that you see on the board, this one is Hooke's law, we have Boyle's law, Charles' law, Gay-Lussac's law. All of these equations that you see on the board are nothing more than direct, inverse, or joint variations. Okay, so if we look over here for a moment, I'm going to explain these at the end of the lesson. Okay, this is Boyle's law, this is Charles' law, this is Gay-Lussac's law. Okay, P represents pressure, V represents the volume, and T represents temperature. These are called gas laws. Okay, and believe it or not, you are looking at the top one is inverse, okay, inverse variation, and the bottom two are actually direct variation. They look backwards from what we've learned. It doesn't look right. Okay, but I want you to explain the way we teach this topic in math class and the way that this topic is taught in science or used in science are different. Okay, in science we're concerned with let's get the answer. Okay, in math class we're concerned with why. Okay, or theory behind something. Okay, so the methods are different. But in science, these equations are much easier to use and much faster. And we're going to use something very similar, equations that are very similar to this, or actually identical, to arrive at a way to check our answers and arrive at solutions more quickly. So I don't want this lesson to confuse. Okay, the method that I showed you in video 1 is the method that will be emphasized on your Algebra 2 SOL. Okay, you have to write an equation and you have to write a list. But this method, okay, these equations do not require a list. Okay, in fact, the equation is much faster to solve. So I want you guys to at least be familiar with this so that when you go to your science classes and you see these things appear, you will see your gas laws when you take chemistry. All right, when you see these things appear, you're going to go, oh, I've seen that before. I know what that means. Okay, so I don't want you guys just to learn it the way that I showed you in video 1, but I want you to be aware of this alternate process. Now, up here, okay, this is a physics equation. It's called Hooke's law. Okay, let me remind you guys, before we do this, let me write them on the board. Again, from last video, y varies directly as x. Y varies directly as x is y equals kx. Y varies inversely as x is y equals k over x. Remember, directly means put x in the numerator. Inversely means put x in the denominator. If you're struggling with this, rewatch video 1. Okay, now y varies directly with x and inversely with z. Remember, directly on top, inversely on the bottom. And lastly, y varies jointly with x and z. Okay, is the equation. It's the oddball. Okay, in fact, these two equations are actually saying nearly the same thing. Okay, just written in a different form, but I'm not going to get into that right now. So joint is sort of like your oddball. Everything's written in one line. Okay, but over here, force equals kd, F equals kd. What is this? Okay, this looks like what? This looks like what? Direct variation. I told you in the last video, direct means they're doing what? They're doing the same thing. Either they're both going up or they're both going down. Okay, so what is this saying? F represents force and D represents displacement or distance. Okay, so we have force and distance. This is talking about a spring. Okay, so it's like this. Okay, direct means they're doing the same thing, either both going up or both going down. So let me say it like this. As the force goes up, the distance goes up. Or let me say it this way. As distance goes up, force goes up. Okay, so let's think of this. A spring. If you take a spring, okay, you grab a spring, a strong spring, and you pull on it. Okay, as you stretch the spring, as the distance that you stretch the spring increases, the force increases. Okay, the more you stretch the spring, the bigger the distance gets, the more the force. Okay, the greater the force. Okay, so as the distance the spring is stretched increases, the more the force increases. Okay, so they're doing the same thing. Okay, this is an example of direct variation, and it looks like what we learned in math class. So the equations can be written like you see them in math, the way I showed you in video 1. Okay, F equals kd. But if you look over here, Charles' law is also direct variation, but it looks completely different from this equation. I want you to notice something is missing. Something is missing. What's missing? What is in this equation that is not in this equation? Okay, we have two variables, f and d. Here we have two variables, f and t, or v and t. V representing volume, t representing temperature. Okay, but what do we not have in this equation? We do not have constant. We do not have k. We do not have the constant of proportionality. I'm going to show you how to take these equations and eliminate the constant. Okay, so watch this, watch this. I'm going to erase this off the board. Okay, and we're looking at y equals kx. Okay, so what we're going to do, I'm going to take these bottom two off the board for now. We're just going to focus on direct and inverse. In fact, maybe take inverse off for a moment. Just do direct. Okay, so if we take direct variation, watch this. And I write y equals kx. I can get k out of this equation. It's a trick. Watch. So we're going to get k by itself first. So first, to get k by itself, since x is being multiplied with k, divide by x, we end up with k equals y over x. Now, so the constant is equal to the y value divided by the x value. Now, I hope that all of you can agree that are watching. Do you agree that k is equal to itself? Whatever k is, k must be equal to itself. Yes. Okay, k is equal to itself. Now, what is k the same as? K is the same as the y value divided by the x value. So we can say, well, let's replace k with y divided by x. So we have y divided by x is equal to y divided by x. Look at this, and look at this. Okay? This is direct. So we're going to say that y1 divided by x1 is equal to y2 divided by x2. Or take the first y value divided by the first x value is the same as taking the second y value divided by the second x value. Or taking the values in the list. The first y value divided by the first x value is the same as the second y value divided by the second x value. Now, so we have an alternate form for direct variation. So I'm now going to write, okay, just if you need to, you can rewind the video and re-look at this, but I'm going to erase this and rewrite it. So for direct variation, we either have y equals kx, or we can use the equation y1 over x1 is equal to y2 over x2. Notice that there is no k value in this equation. Now, I'm going to show you inverse for a moment. So if we look at y varies inversely as x, y equals k over x, okay, we're going to do the same thing as we did with the direct. We're going to get rid of k. Okay, so we're going to write the equation y equals k over x, and we're going to get k by itself. Now, if k is being divided by x, we multiply by x, cancel. So we get k is equal to x times y. Now, everyone agrees k is equal to x value times y value. So now we're going to write, hopefully you agree, that k must be equal to itself. K is equal to itself. Now we're going to take x times y and replace k with that. So we're going to have x times y is the same as x times y. Now we can say that x1, y1 is equal to x2, y2, or what this is saying, the first x value times the first y value is the same as the second x value times the second y value. This equation and this equation mean exactly the same thing. They find the exact same answer. This is what you learn in math class, and this is what you learn in science. I want you to notice x1, y1, x2, y2 is the same as p1, v1, p2, v2, Boyle's law. Okay? Or this is an inverse proportion. Okay? Or x and y are inversely proportional to one another. So we also have, I'm going to erase this, we also have that inverse, another way of writing the inverse proportion, y equals k over x. Another way of writing this is y1 times x1 is equal to y2 times x2. Now I want you to notice something. They look backwards. Okay, notice direct looks like inverse and inverse looks like direct. Okay, so this is where the confusion comes in. Students get confused. I don't want you guys to worry so much about these two equations. I just want you to be familiar with them. What are we focusing on for our SOL? We're focused on y equals k over kx for direct and y equals k over x. This is what I need you to know. Okay, this is what I would like you to be familiar with on the right. This is what I want you to be familiar with. But soon, after I've introduced this and made you guys aware of it, I will then basically take it back out of the class and we will focus just on these two forms. Okay. but I want you guys to know. So let's look at some of the problems in the book, okay? Doing what we did yesterday. Okay, I'm going to pick another problem. Let's go to page 590. Page 590 in your textbook, number 1. It says if y varies directly as x, so we write our equation first. What do we write? We're going to do what we did yesterday in the last video. Write the equation, then write the list. Okay, so y varies, it says y varies directly as x, so we write y equals kx is our equation. Our list says y equals 12 when x equals 8. Again, this is problem number 1 on page 590 of your textbook. Okay, y equals 12 when x equals 8. Find y, so y is blank, when x equals 14. Now I want to talk about this for a moment. Okay, so what did we say direct means? Direct means they're doing the same thing. As one goes up, the other goes up. Or vice versa, as one goes down, the other goes down. So notice, what is happening to x here? X is going what? X is going up. So what is going to happen to y? Y is also going to go up. So do we expect to get an answer that's bigger than 12 or smaller than 12? Okay, hopefully you say x went up, y is also going to go up, so we expect an answer that is bigger than 12. Now using the method that we learned yesterday, we're going to use the part of the list that does not have a missing value. We're going to start with the top part. So we're going to put 12 and 8 in. We have 12 equals k times what? 8. K times 8. Now, we have to get k by itself. Since k is being multiplied by 8, divide by 8, divide by 8. We get k equals. Now we can reduce this. What divides 12 and 8? Make the numbers smaller. Divide them both by 4. 12 divided by 4 is 3. 8 divided by 4 is 2. Remember, k is not our final answer, so leave it as an improper fraction. K is 3/2. Now, once we have k, we're going to use k and x to find y. So again, we're going to use k and x to find y. We use our equation. Y equals, k is 3 over 2, and x is 14. So 3 over 2 times 14. And how many times are you guys going to see number times fraction in this class, guys? A lot. Okay, so is it easier to multiply first or divide first? Hopefully you say divide is easier. So 14 divided by 2 gives 7. And 7 times 3 is 21. Okay, so again, divide first. 14 divided by 2 is 7. 7 times 3 is 21. So we get an answer of y equals 21. And my question is, does that make sense? Okay, does that make sense? Yes, it does make sense. Oh, it does make sense. Because we said as x goes up, we expect y to also go up. Okay, so y of 21 makes sense. Now, this was all fine and dandy. It took a couple steps to get our answer. I'm going to show you that this equation gets our answer almost faster. Okay, so we understand that our answer is what? Our answer is 21. Okay, so I'm just going to write that over here in the corner, and let's circle it. So we understand we have an answer of 21. I'm going to now erase it, and let's act like we didn't know what the answer was. Okay, so let's use this other equation. Let's see if this other equation, the other representation of direct, which actually looks kind of like your inverse equation. That's the confusion here. Okay, this other equation for direct, okay, can be used to solve this. Watch. Okay, so y1 over x1 is y2 over x2. Here. We write y1 over x1 is equal to y2 over x2. Now, what this means is take the first y value and the first x value, put them together. Take the second y value and the second x value, put them together. Or list 1, list 2. So let's take the top list, y1, we call this y1, we call this x1. Okay, the top list, okay, 12 and 8. So we're going to do 12 is y over 8 is your x1 is equal to y2 over x2. Now we don't know y2. Okay, we don't know y2, but we do know x2. So we're going to say y2 over what? x2 is 14. Now when you have an equation like this, you can cross multiply. I don't like this method because it gets confused. Don't get confused. Cross multiplication, cross multiply, cross multiply. Okay, well I'll show you how to do it first, and I'll show you what not to do. Okay, so cross multiply. Okay, so we're going to take the bottom, multiply by the top here. 8 times y2. You can just think of this as 8y. Okay, let's just ignore the 2. 8y equals 12 times 14 is 140, 168. Okay, so 168. And now we're going to divide by 8, and we get a y equals, y value of 21. Did we get the same answer? Yes, we got the same answer. Okay, so you may say, well, that doesn't really save us any time. Well, I think this doesn't show it as much Okay, but actually this allows you to avoid writing a list, really. I mean, you don't have to write anything except, and you're done. But I think when we do the inverse, you'll really see the difference in time. Now, going back to this cross multiplication step, okay. Students see cross multiplication, they think they can cross multiply all the time. Guys, cross multiplication, what is between the fractions? Here. What was between the fractions? What was between the fractions? Equality. That's an equation, guys. When you have an equation, remember our three branches of algebra, your expressions, equations, and functions. Okay, this is equation. When you have an equation, you can cross multiply to solve for the variable. Notice, this is an equation. What if I write this? 3/4 multiplied by 7 halves. 3/4 multiplied by 7 halves. Now, do you guys see equality between the fractions? No. This is not an equation. This is a multiplication problem. This is an expression. It has a value. Okay, we've spoken about that in previous videos. Okay, we take what? 3 times 7. We multiply the top. 3 times 7 is 21. 4 times 2 is 8. We do not cross multiply. We take top times top, bottom times bottom. 21 over 8, which is 2 and 5/8. Okay, 8 goes into 21 twice with 5 left over. Okay, so 2 and 5/8. All right, so I don't want you guys to think anytime you see two fractions, you cross multiply. Okay, so let me do that again. Okay, cross multiplication only works when you have an equation or you have equality between. So 12 times 14 is equal to 8 times y. Okay. So 8 times y is equal to 12 times 14. 12 times 14 is 168 divided by 8. We get y equals 21. So we got the same answer. So the equation does work. This equation works. Now, I'm going to erase these. I'll put these back up on the board at the end. And you will have to know these. We're going to use this space to do an inverse. Okay, so I want you guys to look at page 590. Page 590, number 3. Page 590, number 3 says if y varies inversely as x. If y varies inversely as x. So we're going to do our first, what we did in the last video. We write an equation and write a list. Y varies inversely as x. Y varies inversely as x is y equals k over x. Remember that we put x in the bottom. Okay. It says y equals, now we write our list, y equals negative 18 when x equals 16. Find x when y equals 9. Now, we start with the part of the list that does not have a missing value. Start with the top. Okay, so we throw these values in to find k. So we get y is negative 18, so we get negative 18. We're going to do it over here. Negative 18 is equal to k over, and our x value is 16. Now notice k is being divided by 16. Notice we're not interested in the negative 18. We want to get rid of the 16. We want to get k by itself. K is being divided by 16, multiply by 16, multiply by 16. 180, 240, 288. Okay, so we get negative 288. These cancel. Is equal to k. Do we have our k value? Yes. Now we're going to use the k value and y to find x. So we're going to rewrite this. Now I want you to pay close attention. It's a little bit different here. So k is negative 288. So we're going to put in what? 9 for y. We get 9 equals, k is negative 288. Negative 288 divided by x. Okay, we don't know what x is. Now, notice, okay, this equation's a little different. Where is x? X is in the bottom. X is in the denominator. You cannot solve for x if x is in the denominator. Okay, so you cannot solve for x if x is in the denominator. You have to get it out of there. Okay, so how do we get x out of the denominator? Okay, we're going to, notice when we had 16 in the denominator, we multiply by 16. If x is in the denominator, we're going to multiply by x to get it out of there. So multiply by x, and these cancel. And we get 9 times x is equal to negative 288. And now divide by 9, and negative 288 divided by 9 is negative 32. So we get x equals negative 32. Okay? Now, so negative 32. Okay? One way to think of this, again, if we ignore our signs, I'm just going to ignore the negatives for a moment. When I say inverse means they're doing what? Opposite things. In terms of if you ignore your signs, okay? Opposite things. As one goes up, the other goes what? Down. So they're doing opposite. So notice, what happened from x to x? From 16 to 32, it went what? Up. Now we multiply or divide. Multiply or divide. Okay, either or. 16 times what is 32? 16 times what? 16 times 2. Okay, so if we multiply one side by 2, notice, x went up, y went what? Down. Y went down. Okay, so we multiply by 2 on this side. On the other side, we divide by 2. Notice that 16 times 2 is 32, and on the other side, 18 divided by 2 is 9. So if you multiply on one side, you divide on the other. Or another way of saying this, if you multiply by 2 on one side, you multiply by the reciprocal 1/2. So 16 times 2 is 32, and 18 times the reciprocal 1/2 is 9. Okay, so they're doing opposite things. Now, okay, there are some sign problems here. I'm not going to get into that right now. But I just want you to think in terms of ignoring your sign, ignoring your negatives. I'm going to put the negatives back in. This was supposed to be a negative 18, and this is supposed to be a negative 32. Do we understand our answer to be negative 32? Yes. So I'm going to write that down here, circle it to remind us of what the answer should be, and I'm going to erase it as though we don't know what the answer is. Watch how fast the other method works. This other method is so much faster. Again, people that study science are interested in coming to an answer very quickly. They're not interested in all the detail. Just let's get an answer. Okay, the mathematician says, hey, my hand's not really touching this wall. There's an infinite amount of space between my hand and this wall. Why? Because at the atomic level, okay, so here, let me just go off topic for a minute. If this rag represents the nucleus of an atom, okay, it's pretty good. Okay, this is the nucleus of an atom. Okay, it's made up of protons and neutrons. Okay, the electrons are 5 miles down the road, and they're the size of BBs, or the size of grains of sand, 5 miles down the road, and they're spinning around this thing, spinning around this nucleus, I mean, at the speed of light, so fast, it's almost, not the speed of light, but extremely fast, okay? They're just so fast you can't even imagine, but there's so much, okay, here's your nucleus, it's about this big, okay, and your electrons are like the size of grains of sand 5 miles away, spinning around the same. What's between the nucleus and the grains of sand? Okay. A bunch of what? A bunch of empty space, nothingness. Okay, so if we really think, you're nothing but a bunch of empty space. Your body is made up of atoms. Okay, this is the nucleus of the atom, the electrons. Your body's made up of atoms, so you're nothing but a bunch of empty space. Okay, so the mathematician looks at this and says, your hand's not really touching the wall. In fact, the wall and your hand are nothing but a bunch of empty space. What's between the nucleus and the electrons way out there? Empty space, nothing. Okay, so that's weird. That's weird. The scientist says, get over yourself. Okay, I can move the wall, or I can push on the wall. Although my hand may not be touching the book, theoretically, I can pick the book up, I can move the book. Okay, I can open a door, I can close a door, so I can get the job done. So get over yourself, math guy. All right, we can get things done. Okay, so here, looking back over here, the scientist says, we're not concerned with the theory. We're concerned with, hey, can we just get an answer? Let's just get an answer. So watch this. This is so much faster. So this equation is another form of what? Inverse. Okay, so we're going to use y1 x1 equals y2 x2. All right, now, y1 x1 equals y2 x2. Let's look at our list. Actually, let me just read it from the problem. This is beautiful. From the problem. Let's just read the list from the problem. You don't even have to write a list. Watch. It says y equals negative 18 when x is 16. So y equals negative 18 when x is 16. That is your y1 and your x1. Y equals negative 18 when x equals 16. Find x when y is 9. So we're going to put in 9 for y2. Okay, and we don't know x2, so we're just going to call x2 just some unknown x. Now, what did I do? I put in negative 18 and 16 in for y1, x1, and I put in the 9 for y2. Okay, and we don't know x2. So if we call this, the subscript's just being positioned, y1, x1, y2, x2. Okay, so first, second. Okay, so y1, x1, negative 18 times 16 is the same as 9 times something. Okay, now, watch. Negative 18 times 16 is negative 288 equals 9x. Divide by 9, we're done. Look at that. So much faster. X equals what? I'm sorry. X equals negative 32. Okay, negative 32. We got the same answer. Okay, so much faster. Look how much less work that is. We didn't even have to write a list, really. Okay, this just gets an answer very quickly. So these equations, although you do not need to know these for your SOL, they're a great way to check your answer. I like when students do this to check their answers. Now, I will say this, on the test, you guys will be required to do it both ways. Okay, just for the test. After that, you may pick your method until I tell you that, hey, we've got to focus just on this method, because the SOL will test just these two equations. So you have to be very familiar with these. Okay, but I like you guys using this as a way to check your answers. Now, going to the word problem on the board. Going to the word problem. The length of a violin string varies inversely as the frequency of its vibrations. Okay, so this is the same thing in terms of a lot of words. You just have to get through the words and find your keywords. It says the length. Okay, let's read the whole problem. Length of a violin string varies inversely as the frequency of its vibrations. A violin string 10 inches long vibrates at a frequency of 512 cycles per second. Find the frequency of an 8-inch violin string. Now, okay, let's pick out the keywords. The first sentence tells us the equation. We're going to do the equation and list. Okay, we need an equation, we need a list. So it says the length of a violin string varies what? Inversely as the frequency of its vibrations. Pick out the keywords. Pick out the keywords. Length varies what? Length varies inversely as the frequency. Students will say, well, what about the vibrations? Well, hold on. Never mind. Let's just do this. I'm just going to tell you. Length varies what? Length varies inversely as frequency. I think the more problems we do, the more you guys will see this. Length varies inversely as frequency. I'm not going to get into what's measurable right now, but length varies inversely as frequency. Do you see an equation? Yes, let's write the equation. Length, L. Okay, this is how I write my L's. Okay, it's a fancy looking L. Length varies, so K, don't forget your K. Length varies inversely, means put it where? Put it on the bottom. Length varies inversely as frequency. Length varies inversely as frequency. Now, so this is L equals K over F. Now let's write a list. So it says in the problem, it gives you the list. A violin string 10 inches long. 10 inches long, what is that? Is that length or frequency? 10 inches long is length. So a length of 10 inches long vibrates at a frequency of 512 cycles per second. So frequency is 512. Now I'm telling you guys, this is a test question. This is on the test. So take notes on this. I'm giving away a test question right here, guys. Okay, now what else? Find the frequency of an 8-inch violin string. So find the frequency, we don't know F, of an 8-inch violin string. 8 inches your length. So do we have a list? Yes. Now my question is, what does inverse mean? This is inverse. What does inverse mean? As one goes up, the other goes down. So they're doing opposite things. Notice, what happened to length? Length went what? Length went down. So what's going to happen to frequency? If length goes down, frequency is going to go up. Okay, so we expect the frequency to go what? Up. So we expect an answer that is bigger than 512. Now let's go ahead and set it up. We're going to use the top part of the list because it does not have any missing values. Throw this in. So we have 10 for L. 10 equals K over what? 512. Now to get K by itself, since K is being divided by 512, multiply by 512, multiply by 512, and we get K is equal to what? K is equal to 5,120. Now, once we have K, we're going to use K and what? K and L to find F. So we're going to write, since the length is 8, 8 equals 5,120 over F. Now, this is similar to what we did earlier. Okay, where is F, guys? Where's F? F is in the bottom. Okay, can we solve for F if it's in the denominator? No. Okay, what do we have to do? We have to get it out of the denominator. How do we get F out of the denominator? We multiply by what? Multiply by F. Okay, so we're going to multiply by F. Multiply by F. This cancels. Now we have 8 times F equals 5,120. We divide by 8. Divide by 8. We get F equals 640. Okay, so we got F equals 640. And is this consistent with what we expected? As the length went down, the frequency went up. Okay, so yes, this is consistent. Again, guys, this is on the test. So I'm giving away right now a test question. Take notes on this and re-practice this problem. Okay. Now, is there an alternate method to solving this? Yes. Look, if you realize here, the alternate method, using the other equation for inverse, notice, all you have to see is your word what? Inversely. If you see the word inverse, what equation are you using? You're using the equation what? y1x1 equals y2x2. Notice, you can figure it out. You have 10-inch length, 512 frequency, 8-inch length. You don't know the frequency. So what can you say here? Well, we're varying, length varies inversely with frequency. We can say L1 F1 is equal to what? L2 F2. Okay. Again, this can be confused. This gets confusing with direct, but L1 F1 is L2 F2. Why? Because if y varies inversely as x, y1 x1 is y2 x2. Notice there's no k value in this equation. Now, what is the first length? The first length is 10. We can say 10 times what? The frequency is 512. Is equal to, find the frequency of an 8-inch violin string, so the length is 8. And we don't know the frequency. Now, F2, we can just write it as F. That's fine. 10 times 512 is 5,120 equals 8F. And what do? Simply divide by 8, divide by 8. And we have F equals what? 640. Now, in this case, I have to agree. The science equations are faster, they're more efficient, and they're better. I think this is actually a better method. I think this is actually a much more productive method to coming to an answer. So simple. Okay, 640. And this is how the equations will be written when you guys take science. Okay, now, so again, we got 640. So our answers match up. All right, now what I'm going to do, I'm going to solve one more type of problem that I haven't put on these videos yet. And then I'm just going to give you the laws and we're done. So looking at, looking at number 5 on page 590. Okay, this is super important because this is where it all comes together. Suppose A varies directly as B. Now I'm just going to use this method. Okay, these equations over here. Okay, or this type of equation. It's a little different. So number 5 on page 590 says, suppose A varies directly as B and A varies inversely as C. A varies directly as B. Directly as B means put it up top, and inversely it says A varies directly as B and A varies inversely as C. So put C where? Put C on the bottom. I don't like how they write it. They write A varies directly as B and A varies inversely as C. It sounds like two different equations, but you can write this in one equation. A varies directly as B and A varies inversely as C is one equation. Simply stated as A varies directly as B and inversely as C. Okay, we don't have to say A twice. Now, we're going to write what? Equation. I'm just going to stick to this method. Equation and what? For this problem. Equation and what? List. So a list, it says find B. Okay, put them in order. Find B. We don't know B. When A is 8, so I'm putting things in order. When A is 8 and C is -3. Okay, so put them in order. A, B, C. All right, now it says if B is 16, when C is 2, and A is 4. Okay, so we have two parts of a list. What part do we start with? We start with the part that does not have a missing value. We throw these values in to find what? K. So just sticking again with this method, guys. I'm not going to give you the other equation for this. All right, so put in what? 4 for A. So 4 equals what? K times what? K times B is 16 over C is 2. Now, notice we have K being multiplied by 16 and K being divided by 2. So we have to get rid of both. Okay, which one do we start with? Okay, let me say it again. If it's being multiplied, we divide. If it's being divided, we multiply. Okay, so K is being multiplied by 16, so we're going to divide by 16. K is being divided by 2, so we're going to multiply by 2. Which one do we start with? I tell students start with the division first. Since K is being divided by 2, multiply by 2, multiply by 2, cancel. So 2 times 4 is 8 equals K times 16. Now, since K is being multiplied by 16, divide by 16, divide by 16, what do we get? We get K equals 8 over 16 is 1/2. Okay, now once we have K, we're going to use K, B, and C to find, K, A, and C to find B. Let's rewrite this. So K is 1/2, we have A is 8, so we have 8 equals, K is 1/2, multiplied by, 1/2 multiplied by, B over C, which is -3. Now, Okay, B is being divided. We start with the division first. Since we're dividing by 3, or B is being divided by 3, we multiply by negative 3. I'm sorry, B is being divided by negative 3. Multiply by negative 3. Multiply by negative 3. These cancel. Negative 3 times 8 is negative 24. Okay, is equal to 1 half B. Quick discussion here. Okay, 1 half B. You're going to be seeing this a lot in this class, guys. Okay, so do we divide by a half? Is it okay to divide by a half? Yes. If B is being multiplied by half, can we divide by a half? Yes. It's tricky. So we say B is equal to negative 24 divided by a half. My question is, what is negative 24 divided by a half? Okay, I get a lot of answers of 12, and this is not 12. No, dividing by a half is going to make it bigger. It's going to be bigger than 24, okay? So let me write this way. This is going to be a lot. Okay, you're going to see this a lot in this class. Negative 24 divided by a half. So this is negative 24 divided by a half. Do you agree? Do you agree? 24, or negative 24 divided by a half, it can be rewritten this way. Negative 24 divided by a half. Now, what will division change to? We're going to change division to what? Multiplication. So we get negative 24 multiplied by what? We're going to take the 1 half and flip it. 1 half becomes what? 2. So negative 24 multiplied by 2 gives what? Negative 48. Let me do that again. Now, so we have negative 24 divided by a half. This is negative 24 divided by a half, old school. This is old school way of writing it. Division changes to what? Multiplication. So we get negative 24 multiplied by what? What happens to the 1 half? It flips. So we get what? 2. Okay, so flip 1 half, we get 2. 24. Negative 24 times 2 is what? Negative 48. So what is B equal to? B is equal to negative 48. Okay, don't do this. Don't divide by a half. There's a faster way to do this. Faster. We know our answer is negative 48, but faster is to do this. Watch. You have negative 24 equals 1 half times B. Okay, how do we get rid of the 1 half? Okay, we multiply by the reciprocal. What's the reciprocal of 1 half? It is what? 2. 2 over 1. 2. Okay, so multiply by 2. The 1 half and the 2 cancel. You say, what? Hold on. What did we learn earlier this year? 1 half times 2. 1 half times 2. Isn't this 2 over 1? Doesn't that give 1? 1 half times 2 is 1. This is the multiplicative inverse property, guys. Okay, so you multiply by the reciprocal. If you have 1 half multiplied by its reciprocal 2, they cancel. We get B equals negative 48. Okay, hopefully that was clear. Now, lastly, before I shut the video off, I want you guys to write these laws down. We're going to use these, okay? I'm going to give you a quick little explanation, and then we're done. So, we have P1 V1 is equal to P2 V2. This was called Boyle's Law. And what this means is what? Inversely proportional, or as one goes up, the other goes down. Now again, P stands for pressure, V stands for volume. Okay, so what is this saying? As the pressure goes up, the volume goes down, or vice versa. As the volume goes up, the pressure goes down. Let me tell you, I would explain it like this. Take a balloon, okay? If you take a balloon, a helium balloon, you let it go. And it starts floating up into the atmosphere, okay? Eventually, the balloon will pop. Okay, they say you let a balloon go, you watch it, almost disappears out of sight, and then all of a sudden, we never really see it, but it actually ends up popping. Why? Okay, down here on Earth, there's a lot of air above us. The air pushes down on us. It's heavy. We don't feel it, but it's there. Okay, it's pushing down us. We don't feel it because our bodies are balanced. We're used to it. Okay, so it's pushing down on us. It's called air pressure. Okay, so down on Earth, is there a lot of air above us? Yes, a lot of weight pushing down on us. But as we go up, if you go up into the atmosphere, like where the planes fly, okay, way up there, there's not as much air above us. Okay, how much atmosphere is above us if we're way above the Earth? Not as much air. There's less pressure on top of us, pushing on us. Okay, so on the Earth, we have a lot of pressure pushing on us when we're down here on ground level. But up there, there's not as much pressure pushing on us. So what happens as the balloon rises? Down here, there's a lot of pressure on the balloon. The volume is small. Okay, as the balloon rises, what happens? The pressure pushing on the balloon decreases. Okay, as the pressure pushing on the balloon decreases, what happens to the volume? As pressure decreases, what happens to volume? Pressure decreases. They're inversely proportional. As pressure decreases, the volume of the balloon goes what? Up. The volume of the balloon goes up, pop, and it pops. Okay, so this is Boyle's Law. As pressure decreases, volume increases. They're doing opposite things. This is inverse. Next we have V1 over T1 is equal to V2 over T2. Okay? This is called Charles' law. These are called good gas laws. Charles, C-H-A-R-L-E. Charles' law. I think I had that written wrong earlier. Charles' law. Okay, so this is V1 over T1 equals V2 over T2. This V represents volume, okay, and T represents temperature. Now notice, this is direct, okay? This is directly proportional. So what this means, as the volume, remember direct means we're doing the same thing. As the volume goes up, the temperature goes up. Or let's say it the other way. As the temperature goes up, the volume goes up. We can also say it the other way, both going down. As temperature goes down, volume goes down. Here's another way of thinking about it. Take a balloon. This is a little science experiment for you. Take a balloon. Okay, blow the balloon up. Okay, so balloon blow it up. You can get it real good and, you blow it up real good, And so you got this balloon. The volume's big. You blew it up. Okay, go take that balloon, put it in the freezer. Now you don't want to blow it up too much; it might not fit in the freezer. But okay, blow it up and to a size you fit it in the freezer. Okay, what happens in the freezer? The temperature goes what? Temperature goes down. Okay, these are doing the same thing. As temperature goes down, what's going to happen to the volume? It's going to go what? Down. Okay, they're doing the same thing. Go back an hour later and get that balloon out of the freezer and watch. That balloon will be so small. Okay, as the temperature goes down, what happens to volume? Volume goes down. Okay, that's Charles' law. Okay, try it. Blow a balloon up, go put it in the freezer. It's really interesting. Now, we also have P1 over T1 is equal to P2 over T2. Okay, this is called Gay-Lussac's law. Okay, Gay-Lussac's law. Okay. Gay-Lussac's law. And this means pressure and temperature. And this is, again, direct. So as pressure goes up, temperature goes up. Or as pressure goes down, temperature goes down. I think of a good example. As pressure goes up, temperature goes up. Or let's go the other way. Temperature goes up, pressure goes up. Temperature goes down, pressure goes down. Okay, it's the same thing with the balloon. If you put it in the freezer, the temperature went down. What happened to the pressure? What happened to the pressure inside the balloon? It went down. Okay, as temperature goes up, okay, if you go put a balloon next to a fireplace, go take that balloon out of the freezer, go take that balloon out of the freezer, and go put it next to the fireplace and watch it. As the temperature goes up, the pressure inside the balloon, okay, the balloon expands, the pressure increases. As temperature goes up, pressure increases. That's probably the best example I'm thinking of off the top of my head. As temperature goes up, pressure goes up. Okay, go put it next to the fireplace. Temperature goes up, the balloon expands, the pressure inside the balloon goes up. Okay, so temperature, pressure doing the same thing. It's called Gay-Lussac's law. I want you to know the names of these laws, okay, and you will be seeing some of these in word problems as the semester goes on. But anyway, hopefully this helps, hopefully not confusing. Okay, again, our main focus is write what? Write an equation, write a list. Okay.